Good morning. My name is Mr. Hammond, and today we're going to be learning about functions. It's been a functioning year, has it? First, we're going to start off with exponential functions. What is an exponential function, you might ask? Well, if we look at it, it's pretty similar to a regular function. Almost any function you've seen before. But there is one major difference. The variable here now works as the power rather than the base. And exponential values, because of this, generate a much faster doubling period. So previously we have dealt with functions such as f of x equals x raised to the second power, or y equals x raised to the second power, where the variable x worked as the base, and number 2 is the power. In this case, those two are flipped. X will now be the exponent, or the exponential, while 2 will be the base. Let's take a look at this function here. G of x equals 2 raised to the x. Now, if we look at it, it kind of sort of looks like a regular function. But now, we have to look at the base and the power. We have the variable here. So now when we plug in numbers for the x, we have to understand how this doubling period works. So if you plug in 0 for this, then the answer is going to be 1, because anything raised to the 0 is 1. If you plug in 1, the answer is going to be an answer that your base is. And in this case, that's going to be 2. Now, if you plug in 2, you raise that to the second power. So forth and so forth. So forth. So, now, things are going to get a little complicated. Because now we can plug in negative numbers for this. So if we take a look here, negative 1 plugged in for this x. What happens here is that we now have to flip everything to the opposite side of the fraction bar. So 2 raised to the negative 1 equals 1 over 2 to the power of 1, which equals 1/2, or 0.5. Negative 2, which will be the new power, will result in 1 over 2 to the second power, which is 1/4, or 0.25. So on and so forth. So let's take a look at these graphs here. So to the left here, we have the negatives. As you see, it keeps going down. But if you start with like a negative 2 and then work your way greater, then you can have something sort of similar to this graph on the bottom here, where it kind of starts off not touching 0 quite, but then it kind of raises up. And it keeps growing faster and faster. Now next, I mean, I would say I was logging off, but, I got to teach this lesson. We're going to learn about logarithms, all right? This is what we would say are the opposite of exponentials, Kind of think of what subtraction is to addition, or division is to multiplication. It kind of has that same positive negative kind of relationship, if you get me. But a more technical term for this will be to call it an inverse of an exponential. So the relationship y equals b raised to the x is equivalent to log b of y equals x. So now, if we take a look at this log, if we really take a look, there are many different properties, 3 to be exact. You have a product property. You have a quotient property and a power property. Now, after we finish going through these slides, there's going to be another video of me actually breaking down how to do those properties. So now, on the left side of the exponential statement, y equals bx, we can see. I'm so sorry about that. On the right side of log base b of y equals x, It is the equivalent logarithmic statement, which is pronounced log base b of y equals x. The value of the subscripted b is the base. And remember, guys, if there is no given base, it's always going to be 10. And just the b is exponential is always and not equal to 1. So now let's move on to the next one. So now, convert 6 raised to the third equals 216 to the equivalent logarithmic expression. How we want to do this is to convert the base, that is 6, remains the same, but 3 and 216 switch sides. This gives me log base 6 of 216 equals 3. Do you guys get it? Log base 6 of 216 equals 3. So now, if we really want to break this down, which I'm going to do further in the next video, you see the 6, that's the base. The 216 is the product or the total answer that you will get if you raise this 6 to that 3. That is the outlier of this problem. Now let's try another one. Log base 4 of 1024 equals 5. So now we're going to do the same steps, but we're going to work backwards. So now, you see this 4, the 1024, and the 5. What you want to do is flip the 5 into 1024. That way, you can get 4 of 5, 4 raised to the 5th power equals 1024.